Greetings, Explorer. You have tuned into Renegade Files, your unauthorized transmission of paranormal events, unsolved mysteries, and underground cultural analysis. I'm your host, Lex Gordon, broadcasting this show from the Jungle Villa Outpost deep in the uncharted tropics. This is Renegade Files episode 62, Physics Rebel Nassim Haramein, Unlimited Energy and Unified Harmonics. Imagine a world where all things interact harmoniously and unlimited free energy is tapped from the universe without oil, batteries, pollution, or wars over resources. A world where our time and efforts are focused on learning, growing, healing, helping, and thriving. Where there is more than enough of everything and people are free to pursue their livelihoods, passions, and live curious, enthusiastic lives. In the early 1950s, this was the promise of science. Science is often referred to as a single concept, but in reality, science is divided into fiercely tribalistic compartments. This is partly because when we embark on studying any single branch of science, we quickly realize that there are lifetimes of information within each and every field of study, so we have to drill down to a manageable level, and even that presents vast amounts of data. Another reason is that birds of a feather flock together. Engineers speak the same language, as do paleontologists or doctors. So these divisions of science tend to collect followers who read each other's books and spend professional time together. Many become friends, so the world of science has become divided into 100,000 parts. But even among two branches of the same field, such as physics, we have a clear division. Astrophysicists study very large things, and quantum physicists study very tiny things. And they do this with two fully different sets of equations and theories, and so the two don't quite jive. To put it simply, very large things behave in predictable and consistent ways, but very small things don't seem to follow those same rules. This has caused enormous confusion in the world of physics because the very large things are made up of the very small things, so at some level, the two must be able to be understood by a single model of understanding. This division is what caused Einstein to clash with the quantum physicists, and the disagreements persist. But cutting-edge physicists have long searched for a unified theory that could unite the worlds of the quantum with the worlds of the cosmos. On this episode of Renegade Files, we will dive into this cutting-edge world and explore the theories of unified harmonics and energy within the vacuum as explained by Nassim Haramein. This episode contains groundbreaking discoveries and ideas about energy that could very well save the world. They're also very controversial because they go against the status quo, and that is what we love around here. These are enormous concepts, but they're also elegant and harmonious, and easy to understand when explored in a logical progression of context. These are realizations that may very well deliver the clean, productive, and pleasant future we all know is within our collective power to achieve. So put on your white lab coat and your mad scientist glasses, set the flux capacitor to ludicrous speed, and come with me as we explore the cutting-edge science of physics rebel Nassim Haramein's unlimited energy and unified harmonics. Unlimited energy and unified harmonics. Ancient worldviews of oneness. Ancient wisdom traditions understood that the universe is one united system, where all components are interconnected in an elegant symbiosis of energy exchanges. The very word universe means one song. Ancient civilizations understood this unified worldview. They believed that all things were connected, and at the base of all creation was a fundamental energy. The ancient Egyptians called it Ka. Hindus call it prana. Taoists call it Qi, and Jedi Knights call it the Force. Native Americans call it the Great Spirit. It is the source of all things and of the consciousness to perceive these things. This is something that modern science knows, but it's forgotten in the tribalistic divisions of departmental academia. And so the division concepts become a part of our language. We define the sun, the moon, the different types of clouds, the layers of the atmosphere. We define the millions of different kinds of plants, the various ecosystems, the periodic table of elements. All things are given names, and the names define and divide them from all other things. And we forget that the laws of grammar are not the laws of the experiences of life. But the physical reality is that all things are interconnected. Consider a single plant, like a banana tree. There really is no line between the banana tree, the air, the sun, the soil, and the water. All of these things are critical components of the banana plant. Remove any single one, and no more banana plant. The same is true for a person. Our heart, our lungs, our blood, and the air we breathe, the sun that fuels the earth, and on, all interconnected. Remove a single component from that system and no person. So, physicists set out about studying the ways the physical world behaves, and we made calculations to describe the motions of the planets, objects, and things on the Earth, and this allowed us to predict things like motion and weight and mass, and so we're able to explore space and study the plants and animals on Earth, and everything was cool. We developed microscopes, and when we looked at the kind of small things, they acted and moved around in much the same ways as the bigger things, and still, all cool. Then we developed ways to look at and measure really tiny things, like atoms and electrons, and the even smaller things that make up those things, and that's when stuff started to get weird. As it turns out, the smaller things don't obey the same rules as the larger things. Little rules like motion through time and space, and physical reality as we know it. Some really small things can do little tricks like be in two places at once, or move like a particle when we watch it, then move like a wave when we don't. They can seemingly communicate instantly across great distances with no apparent information being transmitted in any way that we can figure out. They can move into and out of existence with no explanation of where they went in the meantime. These antics caused huge arguments between people like astrophysicists who studied the big things and quantum physicists who studied the little things, and the two camps have been arguing ever since. It can be said that because science has been divided into so many distinct disciplines, that we have lost the holistic worldview of the ancients and have moved into a worldview of division that causes a long list of problems we all continually face. We tend to think of all things as separated, so we have no deep understanding of the connections in the cosmos and how these affect us on Earth, or how all people are connected to each other. We imagine that the cities are separate from the woodlands, and that the state parks are separate from the state highways. These are different things, so we treat them as totally unrelated. We don't know how biology is affected by weather, how mathematics affects consciousness, or how architecture influences mental health. But anytime we do look into such seemingly unrelated fields, we find that there are connections and influences. Those who see the value in unifying physics do so for far greater reasons than just making all the scientists get along, or even making the various disciplines realize how they affect one another. The idea of unifying physics extends benefits into vast arenas of energy and understanding that has the potential to elevate humanity and our understanding of the world and our places in it to new heights of harmony and existence. And this isn't just some new age pipe dream. It's a paradigm-shifting physics revolution. And every revolution has its rebel. Nassim Haramein and Unified Harmonics. Nassim Haramein has been on the leading edge of physics for years, and he has solved some of the most troublesome dilemmas in that field by looking far ahead with an open mind while also respecting the teachings of ancient wisdom. He believes that in order to unify physics, we must find what he calls the point of unification. He tells us that ancient civilization had an understanding that the forces of nature existed in a unification of energy. We mentioned a few of the ancient names for this force, but in the language of modern science, we call this force space-time. Space-time is the universal force that connects all things. We all come out of it, and we all go back into it in the end. So, one concept that he explains is, think of space as being full instead of being empty. Right away, let's pause and consider what a staggering shift that is. How deeply ingrained in our lives is the idea that space is just a vast emptiness of nothing, the planets floating around in that nothingness that's even less than air. It's vacant. We live our lives with that concept in the back of our minds. But consider the shift that occurs when we think of space as being full, fluid, solid. Then Nassim tells us to think of the things in space, the stars, the planets, the galaxies, as being not separate objects bouncing around in empty space, but think of those things as being a part of that full space, emerging into form from the fullness of the energy of space. The next leap that Haramein gives us is the fact that in modern science, we have a myriad of calculations that describe natural forces: gravity, electromagnetism, the strong force, the weak force, but nowhere in modern physics do we have a calculation that describes where these forces come from, what generates them. He says it's as if we created modern physics in mid-air without an understanding of what produces all of these phenomena. So this gets good. When scientists tried to solve the equations that describe the structure of time-space, they found that there is an almost infinite amount of energy in the universe. The catch is that we don't see the correlation of that energy in the physical world. In other words, when we calculate the amount of energy in the entirety of the cosmos, there should be an enormous amount of matter that has been generated, and yet, it isn't there. This is where we get the theory of dark matter. Dark matter sounds like really high-end, smarty-pants physics stuff, but really, all dark matter is a made-up variable inserted into the equations they can't solve, to take the place of all the missing matter that they can't account for in the universe, which allows the equations to actually work out, and then we can just go on from there. So this near infinite amount of energy that should account for a vastly more dense cosmos is called vacuum fluctuation. It occurs in the vacuum of space-time, and it is a staggering concept. When we look at the vacuum at a very small scale, the vacuum fluctuates with a beyond enormous amount of energy. How much energy? 10 to the 93 grams per centimeter cubed. This is called the Planck density, named for physicist Max Planck, Planck, who predicted it. This is dense beyond a casual understanding. 10 to the 93 grams per centimeter cubed is 10 with 93 zeros after it, and that's the energy equivalent of grams of matter we see in 1 cubic centimeter of the vacuum of space. How much is 10 to the 93 grams of matter? It's more matter than you would have if you compressed every single star in every single galaxy in the known universe into that single centimeter cubed. So when we go around and try to extract energy from the physical world by burning wood, burning oil, smashing atoms to make heat to boil water and generate electricity, we are ignoring a vastly more energetic source at the quantum level of the vacuum, and in 1 centimeter cube of that vacuum is more energy than all of the stars in the entire universe, not only combined, but compressed into that cubed centimeter. This level of energy could absolutely be described as the source of all matter in the cosmos. And Nassim Haramein also gives us this important distinction. This energy is not coming from somewhere else. It is the result of all things and processes in the universe interacting with each other. A continuum of interaction. So this idea is the cliff edge upon which we can stand and begin to gaze toward a unified view of existence. This is an existence of harmony and order and infinite energy in a very real physical way, not some utopian imaginary way. What's imaginary is the idea that all the parts of the world are separate and exist in isolation from one another. Think about how twisted it is that mainstream science will ridicule anyone who thinks that the systems of the universe are all connected. So if you really want to be ridiculed by a modern physicist, start talking about the ether. The ether was proposed by Sir Isaac Newton as a force with fluid dynamics to help describe gravity. Then it was also used by James Maxwell to explain the electromagnetic field. The ideas of ether as a force were discarded when Albert Michelson and Edward Morley performed their interferometer experiments, and since then, the concept of the ether has had no scientific validity. But Nassim Haramein tells us that the Michelson and Edward Morley interferometer experiments lacked the ability to observe down to the quantum level of the Planck scale, which is billions upon billions times smaller than an atom. So if Haramein is right, and there is a fluid solidity to space-time, and the discarded concept of ether as imagined by Newton and others does exist, then we might be able to see its effects through the concept of frame dragging, which was predicted by Einstein's general theory of relativity. Frame dragging occurs when stationary distributions of mass are affected by objects in motion through that mass. So like the wake of an idling boat pulling water in the direction of the moving boat. If ether exists, then we should see this effect as the Earth moves through space. But because this effect is incredibly minuscule at the surface of a body in motion, an experiment like the Michelson-Edward Morley interferometer experiment misses it. But when we measure distances in very fine increments with a laser measuring the distances between the surface of the Earth and a satellite, for instance, we do in fact see evidence of frame dragging as predicted by Einstein. But as Haramein explains, when science finally measured and confirmed Einstein's concept of frame dragging, which happens when the Earth moves through a mass that demonstrates fluid dynamics, this idea was never reconnected back to the Newtonian idea of space containing a force of invisible fluid which connected the cosmos and which he called ether. So the sum of this connected theory is that we have vacuum fluctuation at the quantum level that acts very much like Newton's ether, and we have also measured the dragging of space-time as the Earth moves through space, which could be said to be the drag of the ether. So according to Nassim Haramein, when we discuss space, and matter within that space, and gravity, which is the curvature of space, that all of these things are the same thing. We know that all matter, so yes, even the largest planets are 99.99999% empty space. So space and matter are barely different. So when we look at the parts of matter that aren't empty space, all that's left are electromagnetic fields interacting with each other. So if, as Haramein tells us, that space is not really empty but a fluid solid of what the old-timers speculated as ether and what can now more accurately be called quantum fluctuations, then we have to make a quantum leap, no pun intended, to understand things not as the academic departments of universities are forced to divide them, So into compartments we call physics, astronomy, quantum mechanics, gravity, electromagnetism, etc., but as a cohesive whole, where the incredible energy of the vacuum creates and is the source of all the matter we see, and even that is absolutely connected to the enormity of the seemingly empty space surrounding it all, and in fact, the two things are one unified experience. You can't have mass without space. You can't get gravity without time. You can't have space-time fluctuations without electromagnetic fields. All of these things are connected through what Haramein calls, quote, this dynamic structure of the quantum vacuum fluctuations. How did so many get it so wrong? Famous self-help coach Tony Robbins talks about the concept of what he calls your 1 millimeter. This is making a small change that gets huge results. The example he gives is from golf. Make a 1 millimeter change in the angle of the club face, and that translates into a huge difference in where the ball will land when you extrapolate it out to 200 yards down the fairway. Or 75 yards down the fairway if I'm hitting the golf ball. That tiny change in the beginning makes a big difference later. So in a sense, this can be said to have happened in physics when scientists first began to grapple with the questions raised by what we know as the double slit experiments. Those were the experiments where particles behave like waves and somehow pass through two openings at once. Unless someone was watching, then the particles behaved like particles and only went through one opening at a time, like good little particles, and the entire experiment turned physics upside down, and the New Agers said, well, it's because your intention affects the particles, and maybe it does, but amid the debate, we have what's called the Copenhagen interpretation of the double slit experiment. So because the ideas of a fundamental energy in the vacuum of space had been thrown out, and the idea of ether was relegated to the worlds of wizards and alchemists, the scientists, namely Niels Bohr in 1920, said that a quantum particle doesn't exist in one state or the other, so a particle or a wave, but that it exists in all of its possible states at once. It's only when we observe the state that the quantum particle is forced to choose one of these possibilities. But this interpretation ignores the field the particles are moving through, but few dared to say maybe the ether affects it, because that idea had been rejected. But then a French physicist, Louis de Broglie, working with David Bohm, developed the pilot wave theory, which uses fluid dynamics to explain how a particle can act as a particle when shot through a single slit, or a wave when shot at two slits, because the fluid property of the energy in the vacuum, that is the space that the particle is moving through, is moved by the particle just like frame dragging moves matter as the Earth travels through space. So it's the waves of the medium passing through both slits that interact with each other and cause the interference patterns that we see, that we used to think was caused by the particle acting like a wave, but really it's just the waves of whatever we call the fluid energy in space, what the old-timers called ether, what Nassim Haramein and others now call quantum fluctuation in the vacuum. So why do the particles behave differently when we observe them? Because when we introduce an instrument into the field, we are also affecting the wave pattern. Just like the wake created by a boat in an open sea looks different than the wake of a boat traveling past an anchored ship. The anchored ship affects the wake, just like the instrument affects the wave pattern, because the fluctuation of energy within the space is now also affected. All of this is explained by shifting our understanding of space as empty to space as full. So when we solve the equations as Haramein has done, we find that this entire universe and everything in it is interconnected in a full solid structure of energy, and when it moves, it changes things. It creates things like mass and gravity and the electromagnetic force, and so we begin to finally see the origin of mass, and the origin of energy, and therefore everything else. The Planck constant and black holes. We talked a little about Max Planck in the section of the Planck density, which is the result of the calculations that point to the incredible amounts of energy in the vacuum. Max Planck was one of the scientists who actually began the study of quantum physics when he set out to explore the production of light from the filaments in incandescent bulbs. Using classical physics, he wrote equations to describe the radiation, so heat and light, generated by these light bulb filaments. What he found was, according to the traditional mathematics, these light bulb filaments should produce an infinite amount of ultraviolet radiation. But that couldn't be right. He wasn't the first person to realize this, but he went through the exercise because he was intent on solving this glitch. This was obviously a problem in the math because that isn't what a light bulb does. So something in the mathematics was wrong. This was called, by physicists at the time, the ultraviolet catastrophe. Why was this viewed as such a problem? Because the calculations used were the same ones that physicists and engineers had been relying on for countless other endeavors, and if there was a mistake in the math, it could lead to really bad results. Disastrous. So Max Planck figured it out, or at least he was able to solve the equation with what he considered a mathematical trick, and he did so in 1918, and he won the Nobel Prize for Physics as a result. So to understand what he did, we need to wade just a bit deeper into the ultraviolet catastrophe. When we talk about something like a light bulb filament, which emits light when it is heated up, we are describing what physicists call a black body. A perfect black body absorbs all the radiation that hits it, and it's also a perfect emitter of radiation. In other words, if you heat a black body to a certain temperature, it will emit radiation within the same spectrum of energy that corresponds to that temperature. For example, the sun is a black body, and so is the element in an electric heater, and yes, the filament in a light bulb. The colors these objects emit correspond to the temperatures to which the objects are driven. At the end of the 19th century, all of our math said that hot objects should radiate an infinite amount of energy at ultraviolet wavelengths, and we know that the laws of energy conservation make that impossible. So Max Planck found out that if the vibrating atoms were not calculated as absorbing energy, but were instead confined to a set of equally spaced apart energy levels, then the predicted amounts of ultraviolet radiation that resulted matched the actual amounts extremely well. So his equations introduced this confined set of equally spaced apart energy levels, and they no longer predicted an infinite amount of ultraviolet radiation from the light bulb filament, but rather predicted what we measured, and everything seemed good. So a photon is an elementary particle that is a quantum of the electromagnetic field. In general terms, a quantum is just a unit of measurement, and in physics, it's the smallest amount of a physical quantity that can exist independently, and as such is used to describe electromagnetic radiation. A photon's energy is equal to its frequency multiplied by the Planck constant, and the wavelength of a matter wave equals the Planck constant divided by the associated particle momentum. And Planck's constant is really small. I think I mentioned it earlier, but it's billions and billions of times smaller than an atom. And Planck effectively quantized or created equations that can measure the electromagnetic field of radiation, so the emissions from a black body, such as a light bulb filament or a star. Now, in simple terms, what this means is that radiation is emitted from something like a light bulb or a star in tiny fragments. This didn't seem quite right to Max Planck, and he hoped that someone would come up with a more elegant solution, but nonetheless, the equations did work, and we were able to, for the first time, predict and measure the radiation of black bodies accurately. So Einstein used Planck's ideas to describe photons as particles knocking electrons out of semiconductors to produce the electric effect. He won the Nobel Prize for that. So in this instance, we see another example of the ways that the compartmentalization of science caused things to develop independently and arguably set progress back a notch. As Einstein and Planck and others were crunching numbers and working on the emerging concepts of what would become quantum physics, Einstein was also creating his general relativity equation to describe gravity, and doing so without considering these two as being at all related. So when you solve Einstein's field equations, you realize that, as Einstein did, the universe is capable of creating black holes. Einstein didn't believe these objects actually existed, but we now know that they do. The amazing part is that these black holes, which are perfect absorbers of radiation, are very similar to the idea of the black body in quantum physics. We went headfirst into black holes on Renegade Files episode 55. Portals, stargates, and wormholes, so check it out. I'll put a link to that episode in the show notes to make it easy for you to find it, and so you can also easily share it on social media or in an email or a text to your freaky friends. That's a free way to help the show grow, and it just takes a few taps in less than a minute, so thank you for doing that. I hope you're enjoying the Renegade Files episodes, and I'd like to personally invite you to join me and the Renegade Files agents on Patreon, where you can check out all of our bonus episodes and tons of other cool content for free for a whole week. And if you decide to stay, you can help crowdfund this show with a small amount of money that's less than a tip on a few beers and a pizza. In exchange, you'll get all of the extra content I put into the Renegade Files Agency Patreon page, and you'll help keep the show ad-free. Thanks to you if you're already an RFA agent on Patreon. You know who you are, you make the show work. So please tap the link to Patreon in the show notes or go to patreon.com/renegadefiles and I will see you in there. Thank you so much. Okay, so this is enough general background on what we're talking about to get us going. And now let's dive into the seriously deep stuff. It's possible that the black body radiation we measure at the quantum level is the result of the fact that subatomic particles are actually mini black holes. This is an idea from Nassim Haramein, and believe me when I tell you it has raised more than a few eyebrows. This concept unites the subatomic world of quantum physics with the cosmological world of the vastness of space in the macro dimensions, and we begin to see glimpses of a unified theory that reconciles the different behaviors of the very large with the very small through the application of black hole physics. As above, so below, right? So what this leads to is the metaphysics of unity. This idea that all things are the same thing, and we know that ancient traditions such as the Buddhist, Native American, Hindu, pagan witchcraft, Druid, all of these old philosophies had a connected worldview. So people like Nassim Haramein contend that these concepts are not just spiritual, religious, or philosophical ideas, but that they are actually the way things work in the physical and energetic world we live in. It's the non-linear interconnectivity of all things that make up the world we experience. What Nassim did was to approach physics not from the reductionism perspective of dividing every component into smaller and smaller ideas, but by studying the fundamental natural patterns of the whole, to reverse engineer from the whole to the part in order to find the solution that unifies physics. Now, all of this sounds clinical, but the reality is, when you go down this sort of holistic process or reverse engineering the map, so to speak, you eventually arrive at a point where you realize that you are the map. There is no separation between your individual self and the world of your experience. You are your experience as the entire universe, and you are the universe glimpsing itself, as is everyone, from near infinite viewpoints. He talks about having moments along the way where he would make a new discovery in the mathematical realms of interconnecting his unified field theories, where he would be so astounded that he would have to stop working for days in order to now integrate this new realization into his worldview. As we delve into the unification of physics, the unified field as Einstein called it, and literally worked to resolve until hours before his death, we begin to look at the solutions to things in vastly different ways. We are at a point where we have reached diminishing returns in so many of our scientific pursuits. The old viewpoints result in pushing against things, because we viewed everything outside of ourselves as something distinct and different. This leads toward destruction of habitat and a million other ills. The old methods of jet propulsion for exploring space, for example. We build bigger and bigger rockets to carry more and more fuel to explode fire out of the back and send a rocket up by fighting against gravity the entire way. But what about understanding gravity on a fundamental level and harmonizing and working with it? Paddling downstream, so to speak, rather than trying to blow up everything that's in our way. So, getting gravity to flow in the direction we wish to go. Harmonizing rather than dominating. And there's another part to all of this. Modern science is so afraid to acknowledge the possibility that the environment, the planet, and the cosmos is reactive to or responsive to the intentions of us as individuals or humans as a whole, because they are terrified to even mention the word God or spirituality in the discussion of accomplishment, because that would steal their thunder. But at the same time, they're obsessed with double-blind experiments for the very reason that they know a person's intention or energy can influence the outcomes of a clinical experiment. They tell us that up to 50% of the time, a sugar pill can cure the same illness as a pharmaceutical medicine. And we know this is merely because the patient believes it will. That's high magic by any definition. Not just force of will, but willingness. So where we find ourselves is within a literally miraculous and incredibly improbable situation, and that is being alive with self-awareness, and that is conscious of our surroundings from atom to universe, and of ourself as an observer within that infinite structure. Modern physical science looks at this as the result of a purely random interaction over vast amounts of time that accidentally created the life we see and are a part of. But the chances of that are staggeringly small. Nassim Haramein has calculated the probability of even a single cell developing from the pure chaos of particles in the universe as being 10 to the 8,886 power to 1. To put the enormity of that number into context, the radius of the entire universe is 10 to the 28 centimeters. So the chances of even a single cell organism developing from the random action of the cosmos is 10 to the 8,886 to 1. But science clings to this random action hypothesis because they're terrified to introduce any higher power than the human intellect into their worldview. But between the steadfast materialism of random particles bouncing around and accidentally creating the consciousness we all seem to be experiencing as human life, some of us exceedingly grateful for every breath of it, and the tendency to jump directly to the pure religiosity of God did all of this, there is some middle ground, and that is in the idea that the system is self-referential. As soon as you introduce the idea that there is a system of feedback, those astronomical odds against complexity of life emerging go down to almost zero, because the system is then able to learn about itself, and so it can produce very large levels of complexity in very short periods of time. Short, that is, as far as the life of the universe is concerned. Okay, so this gets deep, but come with me. By definition, if you have feedback, you must have separation between the developing life and the feedback provider, and you're right back to the God complex, or at least you're right back to the division of unity that the unified theory is attempting to reconcile. But wait, There is also another advanced physical reality we now know as quantum entanglement, where communication, and so feedback, exists outside of time-space. We have no clue how it works, and Einstein railed against it, but it's repeatable and measurable, and its existence is a done deal. We're not going to go super deep into quantum entanglement here, but the gist of it is, if you have two particles that are entangled, you can move one millions of miles away, and when you spin one to the left, the other spins to the left. And so there's communication there that happens instantaneously. We have no idea how it works. We don't understand it at all, but we can do it, and we can measure it, and we can repeat it. So we arrive at this idea that the entire universe could be part of an entangled system with another universe, and it is this feedback between the two which allows each to learn about itself as it expands. That feedback reduces the odds against complex life developing to nothing, and it answers a long list of questions around intelligent life and evolution and consciousness. In practical terms, what this means is that the information in and across the universe may be communicating in a non-linear, instantaneous way across and between all scales within it. So all of those things we think of as boundaries, the boundary of yourself, the boundary of a cell, of a particle, of a plant, a forest, the planet, the ocean versus the land, these boundaries exist among a constant flow of information between and across them, so that all things are learning about all other things continually. The internet is an outward manifestation of that inner feedback construct, and so consciousness is now learning more and more about itself in ways that we never thought possible 100 or even 20 years ago. When this information is transferred across these boundary states, it does so as energy. But we don't fundamentally know exactly what energy is. We have E equals mc squared, energy equals mass times the speed of light squared, and we don't really have a complete understanding of what mass is. And we certainly don't know why the speed of light is the rate that it is, so what we have is a system of physics based on equivalent unknowns. And when we look into the source of that energy, and those are the calculations that Nassim Haramein spent the last 25 years perfecting and proving, we find ourselves at a point of paradigm shift where we realize that the amount of energy within a cubed centimeter of the vacuum of empty space is more than that of the energy in all of the stars in the known universe, not only combined, but compressed into that same centimeter cubed. So if we could extract even a micro percentage of that energy, we could run the entire planet for hundreds of thousands of years with no pollution and no destruction of the natural resources that make up the ecosystems of the planet. Now, it can be argued that on a fundamental level, these are not new ideas. Nikola Tesla said much the same thing. Other scientists have had similar ideas, but those ideas were brushed aside largely because people, or the powers that be, were not ready to hear them. So this becomes a consciousness conversation. Are we, as a collective, ready to make that paradigm shift away from dominate, force, and control, and into harmonize, flow with, and unify? We spend so much of our time worrying, fighting against, and blaming that our civilization has become exhausted by the futility of such a huge system, a bureaucracy of ineffectiveness. Every time we choose a new leader, all they do is make it worse and blame the person before them. If our current economy is the fault of the guy who ran it 4 years ago, why don't we just elect a new president every 8 years and then let them take 4 years off in between? This is why Thomas Jefferson said government is best which governs least. History is littered with the bones of giant centralized allocation of resources not working. This is why a dictatorship will always seek to eliminate historical references, because it becomes a single-minded, self-serving mechanism of rent seekers. Someone like Nassim Haramein looks outside the box of old ways of thinking that put us all into categories and imagine that those labels define who we are and what we can accomplish. But in reality, we are all part of the same system, regardless of national boundary or boundaries in any sense. Now, you'll have no trouble finding a long list of websites and articles calling Nassim Haramein a pseudoscientist and discrediting all that he says, but this is to be expected anytime someone goes against the mainstream, especially mainstream academics. So what are the practical applications we can expect from the physics of a unified field theory? Happening in labs right now, we see the development of gravitational beams that have the ability to affect the gravitational force of an object at a distance. The implications for locomotion that result are things like manipulation of the gravitational force in a localized field that makes motion instantaneous and seamless across vast distances. At the same time, if we're going to expand our physical presence in the universe and move as a species into other planets or star systems, we must also expand our consciousness to understand ourselves not as conquerors of space and time, but as citizens of the whole. It's okay to be hopeful for the future. It's okay to point out the mistakes that we make along the way so we can improve. And it's okay to be brave, to be vulnerable, and to be grateful for the chance to experience the universe and to learn as we go. Thank you sincerely for exploring the ideas of physics rebel Nassim Haramein with me today. Subscribe and follow Renegade Files now, so together we can meet again soon and dive into the deepest covert stories where logic clashes with the official narrative. I am so glad to have you in the Renegade Files crew. Until our next adventure, I'm your host, Lex Gordon. Stay wild, ragamuffin child.